All right. So let's start this off. First off, we got a bunch of new terms. Center should be familiar. That's the middle of the circle. Radius, you should know a radius is from the center to the edge. Chord is a new word. Chord is when you have a circle and you just have a line that goes from one edge to the other edge, or ends at the edge of the circle. And particularly, if it goes through the center, we call that one a diameter. So a diameter is a special type of chord. But chord, by definition, is just a line hitting the edge on both sides. So it's like a line inside the circle, essentially. Diameter, we should know, that's double the radius. It's like from edge to edge, crossing the circle. Secant is a new word. Secant is when you have a circle and you have a line that goes through it, in and out. So a chord only stays inside. A secant would go all the way through, in and out. And tangent is a line that hits the circle exactly once. So how does that look? It basically scrapes, a little bit missed. It basically scrapes the side of the circle. Very important, it only hits the circle once. It's a tangent, okay? Where it hits the circle is called a point of tangency. And if two circles share a tangent, it's a common tangent. Okay, so those are all the terms. I typed that into the description of the Google Classroom, so you don't have to rewrite them necessarily, unless you want to. So, Jay, what's your question? Oh. Jay, you gotta unmute yourself. I unmuted you in accident.
I did unmute myself, and then just.
I muted you in accident. Go ahead.
So tangent is something that scrapes something, correct?
It scrapes the circle, very particular.
And the point of tangency is
where it scrapes it.
Where it scrapes?
Yeah, like where it hits the circle.
Oh, okay. And common tangent is
two circles having the same tangent. And we're about to go over these problems to see the examples. So let's start with B. B is right here. B is not the center of a circle. That part of tangent hits a circle, particularly tangent BH. So the point of tangency. So number three is G.
That point of tangent?
Yeah, point of tangency, okay? Number 4, BH, so line BH. So you see here, this BH hits this circle and this circle also.
H, right?
It's line BH, so what is it?
It's a common tangent.
Good, H, good.
Wait, why isn't 3H?
Why isn't 3H? Number 3 is just point B. So it's literally just this thing. It's not a line. It's just literally that right there. So then let's keep going. Number 5, line segment AB. So this is chapter 1 skills. Line segment AB. It's only from here to here. It's a line inside the circle that hits the edges of the circle and it stays inside. Because it stays inside, that is a chord. So that's going to be C. Now, line AB, so that's the arrows, it continues on.
That's a secant, or however you do it.
That is secant. Secant should feel familiar from trigonometry. Did we talk about the inverse ones with 1 over?
I don't remember.
Yeah, we did. I'm going to hope we did. So E. So that's secant. So see the difference? A chord stays in the circle, secant goes through the circle.
When you first said that, I was confused because I was like, oh, I thought that the AB, but when it was just the line AB, I thought it was the E.
Yeah, we got to remember our symbols for lines. So, okay, let's go to the next set, and I'll do it in green, just to indicate we're doing something different. AE, so line AE, which is this line right here, it hits the circle exactly once. It doesn't have a second circle to be tangent to. So this one would just be a simple tangent, so just F. So just to be clear though, BH is also a tangent, but common tangent would be more accurate because it's also sharing it between 2. So technically 4 could be just tangent, but there's the more accurate answer. So we want to pick the best one. The best describes it. Point G. G is in the center circle. We have a very simple name for that. That's center. So that's A. Line segment CD. So it starts from here to here, from the center
Radius.
to the A edge. Good. That's what we should be familiar with. The radius.
Yeah.
And then from edge to edge of the circle, but passing through the center, that's a diameter.
D.
Yes, which is D. Now, a diameter is always a chord. Not every chord is a diameter. So technically, chord would work, but diameter is definitely more accurate. All right, I'm going to the next page after this. Just want to know any questions on this section.
Wait, did we just do the questions that the homework's based off of?
Yes,
And if so, wait, what's the homework again? Is it just these questions?
these questions and the next page questions, which
Oh.
is when I look at it, I know what it is. Okay. Any other questions? Okay.
Is that the
let's
whole
go-
homework?
No. So
More.
let's go to the next one. 21 to 26 is our homework. Also, let's just say also. Let me see.
21 to 26.
21 to 26. Okay. So 21 to 26. 21 to 23 is their own type, and 24 to 26 is the other type. So let's do 21 first. Now, here's a rule about tangents. And this chapter is called Property of Tangents, so it talks about tangents. A tangent and a radius are perpendicular. Because they're perpendicular, they form a 90-degree angle. Because they form a 90-degree angle, we can make some right triangles.
Oh,
So we
man.
have a situation right here on this circle. And it looks like a right triangle. So if I wanted to find the radius, given the information I have, I could use something that tells me the sides of a right triangle, Pythagorean theorem.
You
So
have
why
not-
don't we set that up? A and B are always the legs, of
Isn't
the
it-
right triangle.
isn't it A2 plus B2 equals C2?
Good. A squared would be more proper.
Oh, sorry, A squared.
So
So
it's
R
A squared plus
R
24.
squared plus 24 squared. Now here's very important though. A hypotenuse is not just R, is not just 16. It is R plus 16 squared.
What?
It's the length of this whole line, C2, there's no letter here, but
Mm.
this whole line is R plus 16. Well, I don't know what R is, but I know it adds up to the big line. So I'm going to do this over here. What does, I'll rewrite it as 16 plus R. Actually, no, I'll do R plus 16. So I'm going to say R plus 16 squared. I'm going to tell you this. If you do this, I'm going to mark it wrong on your test every time. If you do R squared plus 16 squared,
But O is not squared.
it is incomplete. It's incorrect. Do not distribute the square like that. Do not do that, okay? What you have to do when you square something in parentheses is rewrite the parentheses as R plus 16 times R plus 16. It's not as convenient, but that is the correct way to do it. After that, we could FOIL or distribute everything to everything else. We're going to do 4 distributions. I'm going to do it quickly, but you guys could practice this in the next 2 examples. R squared plus 16R plus 16R plus 16 squared, which is 256. I'm combining like terms, which are only 16R and 16R. So for my final piece here is R squared plus 32R plus 256. Okay. So now I can rewrite this as this thing over here. So R squared plus 24 squared, I'm going to pull out my calculator for that, equals that thing we just wrote, which is R squared plus 32R plus 256. R squared
Wait,
is
Mr. Tobal, how did you get 25?
576. 25
Tobal.
where?
It says 25, 16R plus 20.
256. 256, that's 16 times 16.
Yeah.
Okay. And then over here, it is r squared plus 32r plus 256. Now, first off, we want to get all the r's, all the variables to one side. I'm going to move the r squared here, but minus r squared, what's really nice is that since they're both 1r squared, they both cancel out completely. So then you're left with a very basic equation. 576 equals 32. Let me pick a different color. Equals 32 r
10. The
plus
answer's
256. Looks Daniel's ahead of me, so I'm going to subtract 256 on both sides.
320.
320? Oh, 320, yeah, that's right. 320 equals 32r. And then divide 32r on both sides.
Well, we know what R equals.
Well, r equals what?
10.
10.
Because 32 times 10 is 300.
Where did you get 576?
576 is 24 squared.
Can we try doing the next one?
Yes. So everyone, you could write this down. Everyone is going to do 22. Try it by yourselves right now. You're going to type privately to me the answer so I can confirm with you, okay?
Can you erase the board?
Erase at least this top part right here. Maybe people need the black part. Okay. So everyone try number 22. I'll write the first part for you guys in case if you feel a little stuck. You're going to send me privately the answer in the Zoom chat, basically because I don't want you to scream out the answer, and I can confirm for you if you got it right or wrong. You're going to get a decimal / fraction. You can leave it as a fraction if you don't have a calculator on you. But you will get a decimal / fraction. Uvi's number one who finishes and got it right. Ethan, you also got it right, just right after her. I'll give you guys 3 more minutes to keep trying it. Good job, both of you, though.
Mr. Wall, I'm
Yeah.
not understanding anything that we're doing right now. Yeah, because I don't understand the homework. Because did you send it? Were we supposed to watch a video before this? Like, I'm a little confused why we're doing homework.
Daniel, you're right. Abby, the reason I'm teaching it, I just did an example of it. And the reason I do that is just so we could practice this example. But I still make the video because a lot of people still like to use the video to help themselves. And if that's so, then let me leave the video up there so people can still use it. But I don't expect you to watch the video before the Zoom session. I just leave it there for you guys to go back to it if you need to study from it. Okay?
Abby already asked this, but where did you get 576 from?
That is 12 squared. Or 24 squared, I'm sorry. That's 24 squared. 24 times 24 is 576, which is was on the left, let's say. At least.
Well, can I continue? And yeah.
I'm going to do 24 and 25 next. If you want to do 23 while you wait, that's fine. But I'm not going to go over 23 on the Zoom, unless you ask afterwards.
Submit this on Google Classroom after.
Oh yeah, absolutely. Make your life a little easier.
Wait, where did r squared go in the first one that you did?
So r squared, so first off, let me just write this. R squared plus 81, 9 squared is 81. When you FOIL this out, is r squared plus 12r plus 36.
Yeah, and then
Yeah.
you like got rid of the r squared.
Yeah, I got rid of the r squared because what I did is, this is 1r squared, this is 1r squared. So I subtract r squared on both sides. But because
Wait.
they're both exactly 1, they both get crossed out, not just one of them.
I'm very confused right now.
So it's 81 equals 12r plus 36. So you should get to there. Then it's simple algebra, minus 36 on both sides. You should get 45 equals 12r. Divided by 12 on both sides, you get 45 over 12, which you could simplify to 15 over 3. No, 15 over 4, which is also 3.75.
What does it say under r squared plus 9 squared equals r plus 6 squared?
That says r squared plus 12r plus 36.
No, the whole line.
This one?
Yeah.
R squared plus 81 equals r squared, had a little 1 there, r squared plus 12r plus 36.
What was the answer to number 21? I forgot.
Number 21 was 10. Okay?
You do number 24.
Yes. Okay? I just want to make sure everyone got to 3.75. All right, let's talk about 24. 24, 25, 26 are a lot easier, or a lot more straightforward, I should say. Should not really say the word easier in this situations. But here's another rule of tangents. If two tangents from the same circle go to the same point, the lines are congruent, which means the tangent of BA and the tangent of DA, and it says B and D are points of tangency, so we know for a fact they're tangents. So BA and DA are both tangents, and they both land on A. Because of that, you could say this is equal to that.
That seems really easy.
It is very straightforward.
I got the answer.
Whoa, 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 whoa. But either way, 3x plus 10 equals 7x minus 6. Because the lines are congruent, you can set the equations to be equal to each other. Do a little algebra, you get 4x equals 16. And I believe, Jay, if you agree with me, x equals 4.
Yep.
And you know that because B and D,
Right? Did you see what I said?
Elizabeth, oh, hold up. Elizabeth first.
B and D, because B and D are points of tangency, you know that 3x plus 10 and 7x plus minus 6 are equal to each other.
Oh, let me give you the full logic. B and D are points of tangencies, so I know any line from that is going to be a tangent. And because they're both tangents and hit each other at the same spot, you know they're congruent. Okay?
Got it.
All right. Now, for the last section, number 25, 26 is also your homework, but for 25, you have to do it. And if you type in the right answer, you send it to me privately in chat, you're free to go.
What about 24?
We did 24, man. It's 4x. X equals 4.
What about 25?
25, your guys are doing it. And if you get it right, you're free to go. Hoovy already sent me the answer. Hoovy already got it right. Good job, Hoovy. You're free to go, Hoovy, if you want to, okay? So you could get dismissed after you send me the answer privately. And again, I recommend if you want to, you could stay. I'll stay on for a little bit. I don't know what's the next class. I imagine it's like 11:15. If you have a mandatory, I'll let you go. Ethan, you got it. You're good. Jay, you got it. You're good. Both of you guys.
Wait, which one is it again?
Wait, but don't we also do number 26?
You could do it right now and I'll confirm it with you and check your work, but
Wait, which one is it?
number 25 is so you can leave. Abby, you
Okay.
got it. You're free to go. Callie, you got it. You're free to go. And also, I'm using this to do attendance. So if I don't see your answer, I'm going to assume you weren't here.
Mr. Tobal,
Yes.
for 25, do you put them equal to each other?
Yeah. 25 and 26, because they both go to the same point, you can set them equal to each other. Okay. I think I said, Callie, you're good to go. I don't know if I said it out loud.
Thank you.
Hey, no problem. Samson, you got it. You're good to go, my man. Michelle got it. You're good to go.
I need help with number 26.
Ethan, let me think about it. Sam, Ren, you're good to go. Daniel, you're good to go.
I'm still
Number
gonna,
26.
I'm gonna try 26 while
That's
you're here.
fine. iPhone, who's that? Oh, Hanak, you're good to go.
Thank you, Mr. Tobal.
No problem, man.
Have a good day.
26. I think both Jay and Abby, you got it. Zach, you're good to go. You got 25.
I didn't do 26.
Who sent me? Oh, Ethan. I'm sorry.
26.
Ethan and Abby, you both got it. Good job.
Okay. I don't understand. I only understand like 24, 25, 26. Like I don't understand what you did for 21, 22, or 23.
Yeah, I'm
Yeah.
confused too about that.
Thank you, Mr. Tobal.
You want me to do 23 with you guys then? Yeah, see you around.
Yeah.
Can you wait a
maybe-
second until I do 26?
Yeah,
though?
can you also wait a second?
Yeah,
I'm
sure,
very
sure.
behind. You are going way too fast for me.
My bad. Well, luckily it's recorded. You could always rewatch it too.
Oh yeah, that's
Mr.
true.
Tobal, instead of going over 21 again, why don't we just go over 23?
Good idea, Jay.
Was this all the homework?
Yeah.
Okay.
So yeah, after this, you could just upload it right now and don't think about math until Thursday. Zach.
Do
I
you
don't know
mind
if I
to go
said
over
this.
26 quickly?
Sure, 26.
Mr.
Yeah.
Tobal, I got 1.3 for 26. Is that right?
No, look at the 4x and the 4x on both sides. You could subtract that and
Yeah, I
it'll
did.
completely
actually,
eliminate
I
both of them. It will eliminate both of them. So you
Oh.
should be left with 3x squared minus 4 equals -1.
Oh, okay. I
And
see.
work from there. Yeah.
I want to.
Wait, I have a question.
Is that Rivka?
Yeah.
Go ahead.
Okay, for 25, would it be like 2x squared plus 5 squared or something like that?
For 25,
Yeah.
you get 2x squared should equal 8 at the moment. 2x squared plus 5 equals 13, though. That's how you started off.
Okay.
And then I would subtract 5 on both sides. So I should get
Oh,
2.
okay, I got it.
Okay.
Mr. Tobal, I just got confused.
On.
So I'm in the middle of 22, right? And I got like R2 plus 12R plus 36.
Oh,
Okay,
22?
so no, but because I was figuring something out.
Oh.
So, basically, what you do, why did the R squared disappear?
Because after you do the foiling, you get r squared on the left of the equal sign and r squared on the right of the equal sign.
Yeah.
Because I can subtract them, they both cancel out completely.
Wait,
so
can
that's-
you write? So it's R, because you do R to R to 6, then 6 to R, and then 6 to 6.
No. Yeah, that's right. And you foil it and you combine like terms. When I'm saying
Yeah, okay, yeah.
after you combine like terms and
Yeah.
you put it back into the original Pythagorean theorem, that's
Okay.
when you can cancel the r squares out. And you'll see that in 23, which I'm about to do, okay?
Okay.
Can you do 26 first?
26 should be very Zach, you got the answer though. Oh no, you didn't.
No, 26. I just need the ending part. I have 3x
Squared.
squared equals 5, and now I don't know what to do.
It should equal 3.
How do you
Because
get
negative
equal
1
3?
plus 4 is 3.
Oh,
And then
And
you
then
should then it's
what's
easy,
the-
right? Divide by 3, then square root. Okay. Number 23. So the legs are always A and B. The legs are always A and B. So right here and right here are the legs. So we're going to have r squared equals, r squared plus 14 squared.
Equals r plus 7 squared.
Good. And remember, r plus 7 squared should be in parentheses. Very important. Okay. So the left side right now, I can't really simplify that much other than
Wait,
making
why are we setting it up like that?
Why are we setting up number 23 like that?
Yeah.
Okay, so this is right here, and all from 21 to 23 are right triangles. Because they're right triangles and we're looking for a side of a right triangle, and we're not planning to use trigonometry, we're going to use Pythagorean theorem. So this leg is a squared, this leg is b squared. This whole thing right here, Abby, is c squared. I don't know what that number is, but I know it's going to be whatever 7 is and whatever r is. So it's 7 plus r. That's why I have to write r plus 7 or 7 plus whatever, you know what I mean?
Okay.
Okay.
Wait,
So,
I sent him my answer. Did I get it right?
but as I look over here, it's 196. So the left side is pretty simplified. Rivka, that was for number 25?
Yeah.
Yeah, that's right.
All right. Thank you.
No problem. So over here on the right, we're going to have to do some foiling. So I'm going to write it r plus 7, r plus 7. Let's see, who's here? All right, Jay, what is r times r?
R times R is R. Wait, what? Why? Yeah. Wait, what do you mean by that?
Yeah, it's no trick question. Just tell me what r times r is.
R squared.
R squared, good. Who's next on the list? Elizabeth, what is r times 7?
I'm past this in this problem, but r times 7 is 7r.
Good. Abby, what's 7 times r?
7r.
Good, 7r. And then Zach, what is 7 times 7?
49.
49, good.
49R, I'd assume.
It's just 49, no r, if that's what you just said.
Okay.
Okay. So there's only 2 like terms here. It always happens to be the middle terms, 7r and 7r. So I'm going to reduce this to r squared plus 14, because you add the r's, plus 49. So r squared plus 14r plus 49. So on the right side of my Pythagorean theorem, so I'm going back here. I'm going back here. It's going to be r squared plus 14r plus 49. Okay. So the first thing I want to do, I realize there's going to be a big issue if I leave r and r squared. But since this r squared matches this r squared, I can subtract both the left and right side. And that is
that right?
Is that right for what?
You can't
23.
go out.
23?
Yeah.
I don't know. I have no clue what the answer is. We're about to finish
Oh,
it, so
you-
we'll see.
Oh, but I thought everyone did 23 and you checked it.
22, maybe, you mean?
Oh, maybe. Okay.
23 is 3.75.
No, 22 is 3.75.
Yeah, 22 is 3.75. 23, I'm literally solving right now, Elizabeth. So we'll see in a second, okay?
Okay.
So 196. Oh, I'm sorry. Let me finish my big point. R squared, since they're the same amount on both sides, I could cancel them out on both sides, which is really convenient because otherwise then we'd have to do factoring or quadratic equation, which we haven't done in a long time. Literally a year ago, because I'm teaching that to my algebra 1s right now. So 196 equals 14r plus 49. From there, simple algebra, minus 49 on both sides. Should be 30.
It's 147.
147.
147.
147?
147.
147. Okay. So 147 equals 14r. And then we divide 14 on both sides. Looks like 10 and a half to me. And I think Elizabeth, that's where you typed me. I know somebody else
Yeah.
typed me earlier.
So I was right.
Good job. 10.5.
I just need to do it myself.
Okay, I'm going to stop recording because we got over all the problems.
About 26. I never got the answer to that.